So welcome back to the next part of the video series. I mean, we've done, we got Bluetooth working. We got LED turning on off by Bluetooth. We added a servo motor, we can make it turn. We added, OLED because, yes, we need robot to have a face. Last thing we're going to add is now something to make it move forward and maybe backwards later, but forward for now, because backwards is a little bit more complicated. Now, there are many ways you can do this, so just take a guess at how we're going to do this. If you didn't read the title, I mean, it's going to be a DC motor. DC motors. So you could have used servo motor, continuous turn servo. We could have used stepper motor. I'm going to use a DC motor. Main reason? They're cheap. In this project, I didn't say this up front, but I designed it to be as cheap as possible. The best I could do, anyways. So, we're not using a fancy servo. We're using a cheaper servo, just 5 gram. We're not using a fancy screen. We're using an OLED, really cheap one, not even colored. We're not using a continuous servo motor or a fancier DC motor. We're going to use one of these cheapo DC motors. There are fancier ones with metal gears, or even ones that have gearboxes built in, but cheap. Save money. Why do that? But yeah, so we're going to use this DC motor. This is actually one of the simplest ones. DC motors are simple. Hook them up to a battery and, they spin. It's hard to see that, so let's add something maybe better. Yoink. Oh yeah, that's beautiful. So just so you can see it spin easier or better or whatever you want to call it. So these DC motors spin when they're attached to a voltage source, right? Our Arduino can be that voltage source. We don't actually need a second battery, which I'm going to do because, again, money. Cheaper, easier actually. I'm trying to make these easy so that people don't, So if you're just beginning, great, this is an easier project. Or if you're advanced and you want to improve on it, then take it, improve it, make it better, because it very easily can be improved. But yeah, let's get started. So of course I ran into a small problem, which I may show a quick So of course I ran into a small problem when building this first time. It doesn't have enough power. So we're gonna have to use a transistor actually. That didn't work at all. So we're gonna go ahead and upgrade this with a transistor. We need a transistor and a resistor. The transistor type I used, although it shouldn't matter too much as long as it's NPN, is a 2N3904. Right there. So we're gonna use that transistor. We're gonna use a 330 ohm resistor because I couldn't find any of my 220s. That's fine, whatever. It's fine, it works. We're just protecting the pin from any straight current. So that LED can light on, off, servo motor can turn left and right still. So we're gonna take away that LED pin, right? We're just gonna yoink it. It's connected to pin 13, also connected to ground. So we want pin 13 because that's what's turning on and off, right? So pin 13 is that pin right there. Stabify. So we're going to plug this purple wire into pin 13, right? Now we're going to move it to the red board over here. I am going to move it right here for now. Pin 13 is just being put into a spot that is a connection point for a resistor. It will connect to a transistor. Stabby. Transistors are very useful, like I said. If you need more power, this is how you get more power. So for my transistor, this bottom leg is going to be ground. This top leg is going to be connected to my DC motor, which is connected to 5 volts, and this middle leg is going to connect to the pin there. So when I turn the pin on, that'll allow this DC motor's 5 volts to go to ground, and that will allow it to turn on basically. So taking this transistor, stabbing it right in this board. I want to put it right into the line with this ground, but also in 3 other pins at the same time. So if we put this in, hopefully you can see that, it's going in line with that ground, right? That bottom leg's going in line with that ground. Right here. These are connected in a line. That black wire and that bottom leg. This middle leg is going to be connected to this pin via a resistor, and the last pin is going to connect to DC motor. So let's get a resistor to connect the middle pin to this purple. So we connect the resistor right in line with that purple pin there. So we're taking my 330 ohm resistor here, connecting it right in line with that purple pin, stabby it in, stabby. Now we're going to connect this right here, this resistor, to that middle leg, which is right. There you go. That's a little bit better view. Those are in the same line. So stabby it in. Lastly, we have the motor. The motor needs to go red to 5 volts, so we connect this to 5 volts down here. This is the 5 volt line, right? So we're going to put it right beside those wires. Right there. Stabby. We'll take this black wire right here off the DC motor again and connect that to this top leg right here. Uh-oh. Can't get a good angle on this. So many wires. Top leg right here. That's an okay angle. That's better. Stabby. And now, if I did that all right, when I push up, the motor turns on. I push down, it turns off, right? On, off. On, off. On, off. Yeah. So now instead of turning LED on and off, I'm turning the motor on and off, which is great. Now if I put this screen back up here. Got it. Okay, so we got a motor, we got a screen, we got a servo motor over here. So when I take this controller and I turn, I can still turn left or right, right? Then when I turn on the motor here, by pushing up, it's on, right? I can still turn left and right. Which is good, because that means I can move my car forward and turn when I need to. And just to the show proof again, this is hard to do. I'm out of room here. I guess I can put it here. Yeah, you can still see the motor there. Off, on, off, eyes. And there you go. That's basically Bluetooth controlled motor, servo motor, and screen. At this point, we basically have a robot. We just need to put everything together now.